This is topic 6.3, 6.4, and 6.5, mostly about fossil fuels and other fuel types and how they are distributed. At the top is our learning targets, our learning objectives, our learning goals. Those are all synonyms. The first one here is E and G, that comes from the course and exam description. The next one is a little bit more specific of a learning target. Okay, sun produces most of the energy on Earth, both renewable and non-renewable. So let's take a look why. So we have this little graphic down here. There'll be another one later too. But sun through photosynthesis give plants energy, and then it can be fed to animals and then people. So our food energy comes directly from the sun or indirectly from the sun through animals. But then millions of years ago, plants and animals died and were buried, and millions of years of time and pressure turned them into fossil fuels. So our fossil fuels were living things at one time, and that energy came from the sun as well. So that's how you get your fossil fuels. Now, in our renewables, the sun will give us like solar power we think of from the sun. But actually hydroelectric, the water cycle that gives us the water for hydroelectric power is powered by the sun through the evaporation process. The water cycle is powered, and that's from the sun. But also wind. Wind is caused by the evaporation of water and the spin of the earth. And so wind indirectly is caused by the sun. So wind power. Now, there are some that aren't, like tidal power is not from the sun. It's the gravitational pull of the moon. Well, some tidal is the gravitational pull of the sun, but mostly it's the moon, so it's not sun related. And then geothermal is a little bit unclear, mostly not, but it could be the initial power for the planet in the core that gets its heat that powers geothermal, came from the sun. Okay, let's talk about biofuels. Biofuels are biomass that's processed and refined into liquid fuels like biodiesel and ethanol. It's also wood, like biomass is wood, biofuel is not. So biofuel is liquids, biodiesel, ethanol. It's 40% of renewable energy and 5% of all energy consumed in the US today. Here's another diagram of how the sun is used directly or indirectly. Again, our fossil fuels from the past, directly solar, hydroelectric and wind and wood. Wood is direct, wind is indirect, hydroelectric's indirect, and nuclear reaction is really not. So these energy sources are not from the sun. Tidal and nuclear and geothermal are really not from the sun, but all of these are sun related. So you do need to know that. What's sun related, what's not. Most are sun related. There's 3 that are not: tidal, geothermal, and nuclear. Okay, we have modern carbon and fossil carbon. Modern carbon are things like wood and the carbon in our atmosphere. Fossil carbon is our fossil fuels. All right, so most biomass and biofuels are considered carbon neutral, which means they don't really change carbon dioxide concentrations in the atmosphere, because you take in carbon when you grow as a tree or as corn that's turned into ethanol. You take in that carbon from the atmosphere, and then it is burned and you release that carbon back. So really it should be equal, carbon neutral. However, our old fossil fuels, our current atmosphere is different than ancient atmospheres. And so basically when you burn a fossil fuel, no carbon has been removed from the current atmosphere to create that energy. And so then you're releasing all of that energy. Here's our major fuel types in the world: wood, coal, and peat. Peat is a precursor to coal. We'll talk about that. Natural gas, crude oil, tar sands. Wood provides heating and cooking to 2 to 3 billion people in the world. You can see a picture here. This would be probably a developed country like the US. I just ate at a restaurant yesterday up in the mountains where the restaurant had a wood burning heater. I sat because I was cold right next to it. So people in the US do use these, but mostly in developing countries. So this is kind of a big key point right here. Developing countries, people use wood because it's easily acceptable if you live near a forest. So if you're in a lot of the world is forested, and if you live near a forest, you can just chop down a tree and burn it for your heating and cooking. Now, there are still 3 million homes in the US that use it, which I talked about. Now, currently, forests are being cut too fast to allow trees to maintain carbon neutrality. All right, let's talk about coal. Coal is a solid form of fuel from the remains of trees, ferns, and other plants preserved millions of years ago. Mostly used for electricity generation and industrial processes. It can be found in many forms. Let's look at peat. This is a picture of peat. Peat's a precursor to coal, so it's partially decayed vegetation under high pressure, anaerobic and acidic conditions. Make sure you know that. It is in bold for you. This is a peat seam here in, if you're in English class and you're reading some literature that was set in the past in England or Ireland, sometimes they'll talk about gathering peat, and you can go out and dig up peat to heat and cook with in those countries. All right, but they're running out. Remember, they're non-renewable because it's a precursor to coal, so there's some restrictions on gathering peat in modern days because of the finite conditions of peat. Okay, we have 3 types of coal. Lignite is the one that is the least amount of heat and pressure, least amount of carbon, and this is bituminous right here. It also has bituminous also has a lot of sulfur in it, so no, here it has a lot of sulfur. Anthracite is our hard coal. It is the best coal. Okay, so you have to know these tidbits. Which has the highest level of carbon? Anthracite. Which is the best in energy per volume? Anthracite. Which is the least in energy per volume? Lignite. And which type of coal has the highest sulfur? It's bituminous. So you have to know these facts about the different types of coal. Now remember, peat is not coal. It's like on its way to being coal with a few million more years of heat and pressure. So again, here's what happens. You have peat. So it's partially decayed heat and pressure, then more millions of years, then hundreds of millions of years, then lots more millions of years, and you get anthracite. So you can pause this video and read the graphic. All right, natural gas is considered a cleaner source of combustion because it has less particulates, which is a type of air pollution, sulfur dioxide, and carbon dioxide than coal or oil. Most of the gas in natural gas is methane, CH4, and the remaining is ethane, propane, butane. It can be compressed and liquefied for transport. It provides 24% of the total energy consumption globally. The next one is crude oil. So it's a mixture of hydrocarbons such as oil, gasoline, kerosene, as well as sulfur and water. It mostly exists in a liquid state underground. Well, crude oil is a liquid state. Some petroleum is more sticky, might be like semi-solid. We'll get to that in a minute. Oil is used in vehicles, so it can be made into gasoline and diesel, jet fuel. Can also be made into tar and asphalt, kerosene, and you do that by boiling point. So here's a graphic that you can pause and take a look, but you can see that if you distill and use different boiling points, you can create different types of fuels from crude oil, including gasoline, including jet fuel, including diesel and heating oil, etc. All right, here's a type of petroleum. They are sometimes called tar sands, sometimes called oil sands. They are slow flowing, so they're like semi-solid, semi-liquid. They're viscous deposits of bitumen. So know the word bitumen is the particular type of petroleum found in this. They have to mine it. It's near the surface, and so they mine it. Now this is a kind of superimposed picture. This is not a real photograph. They're showing you a photograph here of what the area looked like before they mined for tar sands, and this is during the mining process. So it's super ecologically terrible for habitat destruction. They also burn worse, so they have more air pollutants when burned than regular crude oil. But this is a new deposit. Since I started teaching this class, it's a new type of technology that we can get this petroleum out, which means it has upped our reserves of petroleum, not only in certain countries, but our global availability of oil. Okay, so fossil fuels have specialized uses for motor vehicles and electricity. Now, whenever you convert energy, you're going to lose efficiency. But we try and capture as much as possible. We try and have more efficient through things like insulation and other types of technologies, engineering that help us get more efficiency out of our modern appliances, including things like water heaters or refrigerators. Okay, 35% of the energy in the US is used for transportation. Public transportation is the most efficient method of transportation. Single car drivers and larger vehicles like SUVs and trucks are least efficient. Electric cars and plug-in hybrids make use of electricity as an energy source. Now, are electric cars more eco-friendly? It depends on your state. So when you plug in a car to charge it, where is that electricity coming from? If it's coming from burning coal, then you're still burning fossil fuels. But so it really depends on your state and your town and where do you get electricity from. So in California, where I live, electric cars are better environmentally because our electricity is generated from natural gas and hydroelectric and some other renewables, winds, etc. So it is better than burning gasoline that comes from crude oil. But in other states, coal and oil are equally bad. So if you buy an electric car and you plug it in your house, but that electricity comes from burning coal, it's not necessarily better environmentally. Okay, because you're still burning a fossil fuel, just indirectly. Okay. And electricity is gathered via conversion from a fuel or resource. An energy carrier is a source like electricity that can move and deliver energy in a convenient, usable form to end users. Energy conversion is about 36% efficient, and fossil fuels can release many pollutants in the process. So really, you have your study guide to let you know what sorts of specifics you need on this slide, but just know energy conversion is not particularly efficient, and we lose energy getting it to being used by us. We're going to learn what a thermal power plant is. Thermal means you're burning something to generate heat. So we heat water to have the steam spin turbines to generate electricity. We convert potential energy into electric energy. And then there are some natural gas power plants that use both a steam turbine and a separate turbine powered by exhaust gas to generate more efficient electricity, which is a combined cycle. Okay, let's talk about power plants. The capacity is the maximum electrical output it can handle. And so you need to know that. You also need to know that you can use cogeneration to help with energy efficiency. So for example, here's an example. In an apartment building, exhaust from a gas-powered electrical generator is captured to produce hot water to heat a swimming pool. So a lot of times energy is lost as heat. Well, can you use that heat for something? Can you, instead of just going into the atmosphere and being lost as something useful, remember energy is never lost, but lost as something useful for humans, let's take that heat waste and use it somewhere else. Okay, so here's how a cogeneration power plant would work. You have your turbine being spun by steam, which releases electrons in a generator. That's a very simplified. If you are an engineering kind of person, it's more complicated than this. This is very simplified. Now, there is waste heat produced, and so you can use that in that waste heat to produce hot water for heating or cooling in a building. Okay, there are 11,000 power plants in the US that can generate 1 megawatt, so it's 1,000,000 watts of energy or greater at any time. Currently, the natural gas produces the most electricity in the US. This number has gone way up. Natural gas used to be much lower when I first started teaching this course. Coal has declined, natural gas has increased. And the reason for this is coal has more air pollution, it releases more carbon than natural gas, which is why it's phased out in favor of natural gas. In addition, the increase in fracking has increased the amount of natural gas we have available in the country. Which fuel causes deforestation? Biomass uses trees for heating and cooking or to grow crops for energy. Which fossil fuel is the most consumed in the world for total energy and also for transportation? That's petroleum and crude oil. So little tidbits, fact tidbits. Okay, moving on to topic 6.4, let's talk about fossil fuels and where they're found. Okay, fossil fuels are not everywhere. Coal only forms through organic matter becoming quickly buried. Basically ancient swamps. So you can see that right here. Ancient swamps. Ancient swamps, plants were, swamp trees, swamp plants were buried, and then heat and pressure and time turned them into coal. The US had a lot of this. Not every country does, but the US, Russia, China, you need to know the top 3 on your study guide. And that can flip-flop, like who has the most reserves, who uses the most. Just know the top 3 countries. You don't have to know the top 1 because these things can flip-flop and over time. Okay, so how about crude oil and petroleum? So you've got phytoplankton or microscopic algae in the ocean that dies, and sometimes our oceans recede, so we have more of an ice age, so the level of the ocean. For example, in the middle of the US, it used to be an ocean actually. When the world was warmer, the oceans filled up the middle of our country. That's why you find ocean fossils in the Kansas. Okay, so the water receded, and now heat and pressure and time give us our crude oil. And above that, you can see in yellow is our natural gas. They are typically found together. Note porous rock. Porous means that it has pores, it can fill up, covered by non-porous. So basically it's stuck. So in some places, oil bubbles out of the ground naturally. In a lot of places it doesn't, so you have to drill for it. And it's going to be buried by impermeable. Impermeable means you can't travel through it. All right, going on. So oil produces the most energy globally. So energy includes transportation, electricity, heating, and cooking. So all of those together. So the most energy is oil. The top oil countries are US, Saudi Arabia, and Russia. And so you need to know those 3. How is oil trapped underground? How does porosity and permeability of rock and soil layers trap oil? All right, so erosion and plate tectonics move the crust to trap dead organic matter. Heat and pressure in millions of years transform organic matter into fossil fuels. An impermeable rock can trap oil underground. Porous rock can hold oil and natural gas. Super important to know. Pause the video and make sure you get that down on your study guide. This is a review as well. This is a type of question we've seen on the AP test before. Which energy sources are not derived directly nor indirectly from the sun? Geothermal and nuclear energy. You can also put on their title, actually. Let me do that now. All right, I paused my recording. I added title. The main coal deposits in the U.S. are the Appalachian Mountains on the eastern United States and Montana. All right, going on to topic 6.5. All right, so you need to pause the video and write down our advantages of coal and our disadvantages of coal. Now, on your study guide, you can either, if you want, list them all, or you can just summarize. And then here's our advantages and disadvantages of oil. Again, pause the video, read through it. On your study guide, you can either summarize or list. You don't have tons of room. I really would love you to summarize or to abbreviate. It will help you not have to write so much. All right, how do we extract oil or petroleum? Most of it's done by drilling or pumping in oil wells. There's some offshore in the ocean. We do fracking and mining in tar sands. All right, how do we get oil without fracking? Without fracking, we dig a well past impermeable rock to release trapped oil and natural gas. If oil and natural gas is trapped in porous rock, water or chemicals are forced underground to crack the rocks and release the oil and gas. So that's how fracking works. So we have oil extraction sites that may damage habitat. So you can see here that this is an oil well. Now you have a fragmented habitat, which lowers our biodiversity. Some animals will not cross roads. Spills can also occur and contaminate soil and surface water and groundwater. For example, the Alaska National Wildlife Refuge is near known oil reserves. Drilling for oil here harms wildlife by reducing or polluting a significant breeding and feeding grounds for birds, caribou, etc. So this is at the very northern part of Alaska. What are the risks to offshore? So this is in the ocean. In California where I live, and I go to the beach in Carpinteria, which is just south of Santa Barbara. We can see these offshore as we are enjoying the ocean. So offshore oil drills can, there could be accidents and spills which injure marine life. Specifically, oil coats the feathers of birds, make them unable to fly or float, which means they can't feed or hunt and they starve to death. Oil and chemicals, the chemicals to clean up the oil can be directly toxic and kill fish and other marine life. Oil that floats on the ocean and catches on fire can cause air pollution and release greenhouse gases. Okay, let's talk about natural gas now. So again, summarize our advantages and our disadvantages of natural gas. Pause the video to do that. Now, most of our natural gas is really from regular oil wells. Again, natural gas sits on top of the oil, and when you pump up oil, you get natural gas. And so here's another diagram showing how that happens. Pause the video and take a look at that diagram. Another way we get natural gas is through fracking. It's a fracturing technique. Again, we went over this before on another slide. Water and chemicals are inserted underground. They cracks impermeable rocks that have no natural gas in them. This releases the natural gas, which can flow to the surface and be collected. Here's our problems with fracking. Groundwater contamination and the release of volatile organic compounds. We're going to study VOX in Unit 7. Fracking causes earthquakes. There's places like Oklahoma that had never had earthquakes until fracking came along. The chemicals that are used to crack rocks are proprietary, which means those companies, by law, don't have to disclose what they're pumping underground. And this can get into people's drinking and groundwater if they have well water. Okay, so what are the benefits of fracking? It makes natural gas cheaper and more accessible in the U.S., which has allowed us to reduce coal usage for electricity. Natural gas has less air pollution and less greenhouse gases. Oh, and here's a picture of it. Let me go back, sorry. So, where am I? Here I am. So you can see it's fracturing this rock, and then it can flow easily once it's cracked. So you can pause the video and take a look at that. Now, fracking can also be used to get petroleum oil that's stuck into impermeable rock. The specific form of petroleum through fracking is called keratin. Okay, how is electricity generated? These are the steps. We also went through these on diagram notes, so take a minute to pause the video and make sure you know the steps in a electricity generation. The other thing you need to know is the transformation of energy. So in a coal, natural gas, or nuclear, energy is converted from thermal means hot, heat, through combustion, which means lighting on fire and burning, or nuclear fission, into kinetic energy, the movement of energy, into mechanical energy in the turbines, into electrical energy in the generators. So that's something you do need to know, is those conversions. So here's a diagram of how it works. Basically, you light something on fire or you do nuclear fission and you heat up water. The steam of the water spins a turbine. The fast spinning of turbine releases electrons in a generator. Now, I gave you on your study guide a few links about how electricity is generated in YouTube videos. Make sure you watch those. They're really important. All right, coal-fired power plants are not particularly efficient. Their energy is lost in each step of the way, from burning coal to turning on your light. You do not need to know this math, but you can see it's a 1.6% efficiency. That's pretty terrible. You can also see by this diagram, the second law of thermodynamics shows that so much of it is lost as heat. Some goes to the wires, but wires lose a lot of electricity before they get to your house. So there's a lot of energy lost. So one way that we can reduce greenhouse gases and reduce climate change and air pollution is to increase the efficiency of how we use energy. All right, know what energy quality is? The ease at which an energy source can be used to do work. Higher quality energy sources don't require too much energy to move it from one place to another. Gasoline is a high quality energy source due to its concentrated energy and current infrastructure to transport it. Wood, however, is lower quality due to low concentration of energy and the challenge it takes to transport it. All right, that's it for this section. Kind of a lot, so good job hanging in there.